This video has been made possible by Hey Gears. Up until now, I've created the mould for most of the components that make up the charging stand, but the main body remains the last major piece to tackle. Originally, it consisted of 4 separate components. While assembling it was enjoyable, it wasn't practical for a low volume, one-person production workflow. In line with the theme of efficiency from the previous video, I've redesigned the main body to be one single piece. By consolidating the parts into one component, I've lost the detachable back panel and insert, which covered the path for the cable. To accommodate this change, I've designed a larger cavity through the body so the entire cable is able to pass through. I've designed a matrix mould for the main body so I can resin cast it, and a separate tube that will be 3D printed and inserted into the mould before pouring in the resin. This is what will create the pass-through for the cable, and it'll also prevent the component from getting stuck inside the mould. There's many ways you could tackle this, but I'll explain a little bit more about why the tube can't be part of the master and a bit more about the mould design itself. So if we take a look at the cross-section of the mould, and let's say this is at the point where I've poured the silicone on both halves and the master's got the tube built into it. So we'll have silicone running through the tube, and we'll have to have a split line somewhere. So let's just say it's in the middle. So we can already see why this won't work. We've got a narrow section there and a wide section there. So anything past here won't be able to go out of that smaller opening. And same here, because this is wider, it won't get past that narrow section going that way. So we can't have it in the middle. The obvious place to go is the narrowest point. So if we go there, that would allow the top section to come out, but we'd have the same issue along the bottom, and vice versa. If we put the split line there with silicone above it, all of this will not pass through that section there. So let's just say this wasn't an issue. Obviously, I can't change the shape of the tube at this point because it was an afterthought, and I'm restricted by the pre-existing geometry of the part. So the shape is the shape. But let's, for argument's sake, say it would work and we had the split line in the middle. When it comes to removing the silicone from the bottom, I'd start with peeling this surface away. Then I peel this one away, and then I pull the silicone out of the tube, which has to go this way. All of this silicone can't go this way until the silicone out of the base is removed, because it's just trapped in there. So to remove the silicone from the base, that needs to go that way. But that now can't go that way until this is removed. So you've got this conflict of direction, which will trap each one in. And remember, this is a cross section, but this silicone isn't just there, this wraps round the tube. So we are just looking at this in one plane. So we could alleviate this by moving the split line there, which would work. But remember, we can't have silicone in the tube, because this is just hypothetical at this point, because I am restricted by the shape of it. So to get to this point where we're able to, this is why I've decided to put the tube in there. So by doing that, you can have the split line of each mould just past the entrance of the tube. So those will also act as locators for the tube when I put it into the mould. And we can do the same as I've just explained, removing this portion first, peeling it off that way. That will be able to go down there. And actually what I'd do is probably release this portion first and then pull the silicone out that way, or the part out that way, depending which way you look at it. You'll also notice that I've got an air hole running through both parts of the silicone. This has happened because I didn't want to put the split line running down across that face, just because I didn't want any flashing directly on the surface of the part. So that's why I've put it across there. Obviously this has created a massive undercut, but because it's a glove mould, I still have the ability to peel this off in that direction without it getting trapped inside. Like I said, there's many different ways you could tackle this. There's probably things I've overlooked, as well as different methods. Like you could have had the silicone that's in the base as a third part of the mold. Maybe that would have made things easier, or it could have created more limitations. But either way, this is the most logical way I can see. It includes some overmoulding, which is something I've wanted to do. So this is just the route I'm going to take. So from here, I'm going to print some tubes. I'm going to print some covers to go on the tube. I'll be prototyping them to make sure I've got a perfect fit. And then from there, we can move on to doing the actual mold itself. I'll be printing these on the new Reflex RS. This maintains the same high quality and reliability of the original model with a few key differences. It's got a larger build volume, enabling me to print the mold shells that would have been too big to print on the previous version. It prints significantly faster as well, without sacrificing quality, allowing for more components per batch and quicker turnaround times. Since workflow efficiency has been a primary focus of this project, these added features will help streamline the process even further. I'm using the PARP 10 resin for these prints, as it's a high-speed prototyping resin that's also suitable for end-use components. Before releasing the parts from the build plate, I'm going to drain the excess resin by using the build platform tilting tool. This is a printable component specifically for the RS that can be found in the Blueprint software. From here, I can release the components, remove the support material and wash them off. If you're considering picking up a Reflex RS, I'll include links in the description where you can learn more and get $50 off the already discounted early bird pricing, plus a free bottle of PARP 10 resin if you purchase before October 4th. Once washed and dried, I can set these off to cure. One feature I really appreciate is that I can send the sliced file to the curing station. This automatically loads the correct profile for the resin used, so there's no guesswork or need to remember settings for each resin. Another thing that I appreciate is that this resin cures in 5 minutes, so it makes for a really quick turnaround on prototypes and final parts. Before I go ahead and prep these parts, I need to test fit the covers. The covers close up the large opening on the back of the stand, locating into the tube, keeping everything looking clean. Each cover has a slight variation in the clips, and out of all of them, number 7 seems to fit without any movement. So after using the PARP 10, I think I'm going to use this as my daily go-to resin. It prints quick. I'm impressed with the surface finish, that matte texture to it. So prep work wise, you just sand the supports off, and if you wanted to paint them, it would probably just be a matter of keying them. It cures in 5 minutes, which is just a really quick turnaround. And compared to something like the PAU10, it's really cost effective. That's not to say the PAU10 doesn't have a place, because the only consideration with this resin is that it's quite brittle. With that said, the clips on the cover are really thin, and I have to put a lot of force on them. Well, not a lot of force. They're definitely under tension when I'm putting them in the tube. So the brittleness is going to be application dependent, but I reckon like let's say 90-95% of end use parts, I could use this and then keep the PAU10 for specific situations. The other thing is, Haygears are doing a PAS 10, which is the same formula as the PARP 10, but it's in just a regular bottle rather than the cartridge. So getting it in a regular bottle means just pouring it into the tank, but it also means it's cheaper than the PARP 10. So that will come in at $32.99. So it just makes it even more cost effective per kilogram. Now that I'm satisfied with how the cover fits, I'm switching from the PARP 10 to the PAWR 10 resin for printing the mold masters and shells. This resin is one of my favourite resins due to its durability, making it perfect for the shells since they need to endure being bolted together repeatedly over a long period of time. Other compatible resins include the PAP10, which offers high strength, temperature resistance and precise detail. The new PAWW10 is a water washable, durable and low odour resin, ideal for users sensitive to resin smells and IPA. PAP10 is available in an orange clay variant as well. There are 4 components in total, 2 masters and 2 shells. The masters include sections of the shell that align with the opposing shell, creating a cavity for each side of the silicone mould. What you saw in the animation at the beginning is the 2 shells that are used throughout the entire process, whereas the 2 masters are only used at the mould making stage. Now all the components are finished, I can wash, cure and prep these ready to use. For the prep work, I've sanded off the remaining supports and shot blasted each component with 120 grit aluminium oxide for a consistent finish over all of the surfaces. The first step in preparing the master and the moulds is to add the dowels to make up the air holes through the silicone. I've incorporated some shallow holes that these 2.5mm dowels push into. I've used this method on the previous moulds and it's become my new favourite way of incorporating sprues into a mould. From here, I can bolt each shell to each master and position them ready to pour the silicone. The silicone I'm using is my own edition or platinum cure silicone. I've been sampling silicone and resin over the past few months to have a product that covers pretty much all applications that I typically do. This is Sure 28A and cures in 1 to 2 hours at 25 degrees, making it ideal for quickly producing moulds. This will be available in the coming weeks once the first batch is complete. Degassing the silicone isn't necessary, but I always recommend it if you've got access to a vacuum chamber. If not, you can use the stretch pour method by pouring from about 1 metre high in a thin stream to a single point in the mould. This helps the air bubbles collapse, reducing the amount of trapped air in the silicone. I've angled the mould to pour at the lowest point with an air hole at the highest point. This setup prevents air from getting trapped between the silicone and the shell, directing any air towards a single air hole at the top. I'll also use this same method for the other mould. Since there are air holes considerably lower than the highest point, I can plug those holes with filleting wax once the silicone reaches them, allowing the mould shell to continue filling. So I got a lot of comments on the last video asking why I don't get any cure inhibitions when I use an addition or platinum cure silicone on resin prints. I have had this issue once, but not due to an incompatibility of the two. I've had it where I've glued together a master with CA glue or super glue and I've accelerated the cure of the mould. And I think what's happened there is the heat has caused the glue to gas off solvent and then caused an inhibition, but local to that area. So it's not the same thing, but that's my only experience with it. So my go-to mould release is the Manny's 200, which I'll typically use at this stage, not for release purposes, mainly just as a safeguard so there is a barrier between whatever the master and shell is and the silicone. Or normally I would actually paint the master. That's mainly to achieve a certain surface finish, but by painting it, there is also a barrier there as well. Due to the amount of people who asked and my own curiosity, I decided to test it and not put any mould release on these moulds, just to see if I get a cure inhibition. I'm definitely going to look into this further and run some tests to see which of the variables, so the resin, silicone, or my workflow, is preventing me from getting these cure inhibitions. Because I think if I can figure that out, it'd probably be helpful to a lot of people. Now the silicone's cured, I can remove all the dowels, trim back any excess overflow, and demould all the pieces. In hindsight, skipping the mould release without testing it first was a bit risky. Interestingly, there is some cure inhibition around the edges where the shell and the master meet, but even more interestingly, the main surface has no cure inhibition whatsoever. It's a similar situation with the other mould. While the main surface has fully cured, a small section hasn't. This area was hard to reach due to the depth of the undercut on the master. Judging by the location of the cure inhibitions, my best guess at this point is that the uncured areas are due to insufficient prep compared to the other areas that didn't have any curing problems. This is definitely something I'll keep in mind when doing further testing. Luckily, I'll still be able to use these moulds after cleaning off the uncured silicone. To prep the moulds, I first need to prep the tube. In case any resin seeps into the tube, I'm applying some wax to the inside of the opening. This thin layer will also help make a seal between the tube and the silicone. I am going to spray a light coat of mould release on the mould for good measure. Then I can push the tube in, locating it onto the boss at the bottom of the mould. I can then align the boss on the opposite side of the mould to the tube and set that into position. All that's left to do is attach the remaining shell and the mould is ready for use. The polyurethane resin I'm using, again, is my own. As with the silicone, I want a resin suitable for most applications. It has a pot life of 3 to 4 minutes and can typically be demoulded in 30 to 40 minutes at 25 degrees. This version is pre-pigmented black, but I will have a natural version available as well. Like the silicone, this doesn't necessarily need to be degassed, but I always encourage it as part of the workflow if you have access to a vacuum chamber. This will work perfectly for this pour, as I need to pour the first part slowly and at a low angle to minimise trapped air. Then I'll tilt it to pour at the lowest point, allowing air to escape through the single hole at the top, similar to how I poured in the silicone. A faster curing resin in this situation wouldn't give me enough time to fully fill the mould before it starts to gel. Typically, I always use the pressure pot as part of my workflow to compress any small bubbles in the mixture or any air pockets from the resin pour. However, since there's air inside the tube, the external pressure could compress the air and potentially cause the tube to deform or collapse. I'm going to test this regardless just to see how it reacts and to see if I can use the pressure pot in this workflow or not. Now this is cured, I can demould it and check the results. There is some slight cupping in the tube, so it is unlikely I can use the pressure pot moving forward. It's important to note this isn't a fault of the Part 10 resin, it's simply a result of using the pressure pot for this particular application. The back of the tube has also shifted from the boss and has been in contact with the surface of the mould. This end of the tube is meant to be recessed into the part, so it remains hidden once the cover is in place. Without the pressure pot, getting the pour and angle just right becomes even more crucial to prevent air traps. After a few failed attempts, I've managed to land on the right technique to ensure there are no larger air traps in the mould. The only air hole is a small pinhole directly beneath the tube. To be honest, I'm surprised it's not larger than that, given how thin that section is. While it's not perfect, I'd say it falls within an acceptable margin of error given the circumstance, and can easily be fixed with a bit of polyester filler. To finish this off, I can install the threaded inserts, sand off the pour hole and sprues, then finish with paint. Before assembling everything, I figured this would be a good opportunity to test print an alternative version of the front that I'm currently designing. I want to see how quickly and accurately the Part 10 can handle some of the finer details and use this as a proof of concept before moving forward with this design. Now it's prepped, painted and the inserts are installed, I can also use this in the final assembly. It's still lacking some detail and some of the profiles definitely want reworking, but I do really like this concept now I can see it as a physical part. The assembly process hasn't changed much, aside from having fewer steps. I can load the charger into the holder I printed in the previous video. First, I'm going to assemble one of the cast fronts to check everything aligns correctly, as this is the first time I'm fitting both the cast front and back together. The charger holder attaches in the same way as before, using 4M3 machine screws, and the cast pad fits over just like before as well. Now I can move on to the concept front. I printed this in 2 layers so I'd be able to prep and paint the inside properly. These need gluing together, but in the final version I'll more than likely design it so they just clip together instead. Again, the charger holder attaches in the exact same way, and now that the cable is routed, the cover can be clipped into the back. Then, finally, the pad can be fitted as well. At this point, the workflow is pretty much complete for all the components. Next steps are really just scale everything up, make some jigs for all the molds just to further improve the efficiency and actually start making parts. There's always this debate whether to resin cast or 3D print something. So I'll factor in things like prep time, print or cure times, material cost, material choice, those kinds of things. And in this case, for this component, resin casting seemed like the obvious choice. However, now that the pressure pot is off the table, and I assume any kind of vacuum casting variant is also going to be off the table for the same reasons, I am mindful of ensuring I'm able to get consistent defect-free components every time I cast one. Obviously, there's a margin for error, so any small defect isn't a problem. But if it turns out I'm getting bigger defects that take more time to repair, then any of the benefits of resin casting are just completely diminished. That's not to say that this was the wrong choice or it's something I'm not going to move forward with or a waste of time. I am getting complete parts from it, and it's always fun to design these molds, have a play with things like the overmoulding. So it's definitely been worth doing regardless. But I am just going to see what times it's given me if I was to slice these, how many I can get on a build plate. Because using that past 10 resin, seeing the speeds of it and the curing speeds, as well as how cost effective it is, that might be an option to explore if it turns out I'm not getting consistent parts out of the mold moving forward. It's been cool to see the prototype of this other variant I've been working on. I know I need to go back and sort the carbon fronts out because there has been some design changes, and I know a lot of people have been waiting for those, so I will make sure these are available soon. I do want to thank everybody who's supported this so far, supported the channel. I've been trying to juggle doing this project and filming between my other work, and I am trying to slowly transition into having this as my main thing. So that's a whole other story and thing to navigate. But yeah, I just want to thank everybody, and I hope everybody is getting something valuable from these videos.